This next section I'm going to review the object modeling part, and what I want to do is review this, and then I'm going to move to the lab, and then I'm going to move back to the example. Normally I'd do the concepts and then the examples back to back, but because if some of you may want to follow this, and I try to support that as much as possible, as we go, I will split this up in this way. I'm hoping that this is something that you have seen a bit of before. I'm sure you've talked a lot about aspects of it. I'm going to try to formalize some of it, and really this is a summary review. We're not going to have any special labs, or you'll have one assignment focused on this, but it's something we'll be using over and over and over again in the semester. I think in objects. This is how I think of code. So whenever I'm doing something, I'm talking to you about object modeling. In this part, we're going to discuss some of the concepts you studied last semester and how you use Java to represent important characteristics of objects in the real world. The key phrase here, key word here is model or modeling, or as Dr. Garrido, if you run into him, he likes to talk about simulation. Now, usually we are dealing with real-world objects and processes. Even if we are creating a world like Skyrim or Final Fantasy, we're still dealing in some sense with the real world, because people wouldn't connect even with a game if it didn't act like the real world. For instance, I know in Skyrim, in some cases where if somebody gets killed and they fall down and they're on a step, sometimes their heels are on the step and the body is suspended in space in a perfect cantilever. Wouldn't happen in the real life, but it's immediately, obviously, noticeable to us, and it rings wrong. So we really are connected to the real world. We like our computer programs are about the world. The object-oriented approach is a specific way of looking at the world and trying to extract the characteristics that are important for what we're trying to, the problems we're trying to solve. And there are two important characteristics about things out there that we will note. State, which is the formal word for this, which is descriptive characteristics. If we're trying to describe people, we talk about height, eye color, weight, age, address, number of dependents, yearly salary, GPA, all of these different characteristics. But then we have behavior, things that objects can do. And this is one of the things that object-oriented programming added into the mix, is that objects are not just places where you plunk data down, they actually can do things. Another term for a kind of an object is an actor. So objects can do things. Sometimes this doesn't very well correspond to what we would think might happen in the real world, but we look at the behaviors, we look at the things that happen out there, and that's some of the characteristics of objects. The other thing we do, and this is a very human activity, is we like to group objects together with similar characteristics, and we call those classes. So in the real world, we have objects, things, we identify characteristics, both static and dynamic, and actions, and then we group these objects together. So we can talk about people, which is a class. Or we have individuals. We have a whole bunch of individuals belonging to that class in this room. We talk about computers and so on, coffee mugs and so on. All of these, we are very good at creating classes and identifying them, and then identifying the similar characteristics. When we're creating a program or creating a system, we're generally trying to solve a problem, or we're trying to do something. We're trying to carry out a task or a series of tasks. We're going to talk about that pretty informally in this class. You did that in 2301. You were given requirements and you talked about it. And if you worked with Dr. Haddad, he does a lot of software engineering, and so he probably explained it a little more fully than I will. But we will be more informal about this because it's a beginning stage. But the process, based on our problems that we're trying to solve, we need to pick out the data, the characteristics that are important. So let's say we're putting together imagine putting together the database of students at this university. That's Owl Express, or it's also called Banner. You may have heard Banner mentioned. There are all kinds of characteristics that you can imagine. I mentioned a lot of characteristics about people before, but I don't think you're going to find eye color in there. You're probably not going to find height or weight. You will find GPA. You will find name and address and phone numbers and what courses people have taken and so on. But there's some things you'll find in there, some things that you won't. Abstraction is the process of picking what is important for what we're trying to accomplish. And you can't make that work until you have something you're trying to accomplish. You don't work in a vacuum. Now, once we have analyzed the world out there and what we want to do, then we have to transfer it into Java, and that's where we use Java classes. Classes are used to represent classes in the real world. So if we have identified a group like people or students or employees or club members, then we can create a Java class that represents that group and represents the particular characteristics that are important for what we're trying to do. State characteristics that we have picked out that are important. Again, not everything's important, but the ones we picked out, those are going to become instance variables in Java. Now I'm going to call them instance fields sometimes because I get so many different terminologies out there, but I believe Liang calls them instance variables, and that's what I'm going to try to call them. But instance variables are used to represent state characteristics like your GPA, the courses you've taken, and so on. And during this semester, we're going to talk about extending our toolbox of things we can represent. I mean, if GPA we can represent probably as a double. That's easy enough. But how do you represent the list of classes that you've taken? How do you represent all of those in Java? Now, behavior is represented by instance methods. So we have a very conscious mapping, if you will, conversion. What we see out there converts to certain things in the Java class. This is a process I'm going to call object-oriented modeling. A lot of other names for it. Summary, we start with the real world, we select characteristics that are important, we represent these in Java. And now we have created a model of the world in Java, a computer model. Now, I've already mentioned two things that are important in Java: instance variables and methods. There's a couple of other things that are important, and some of them, because I'm particularly interested in security and some of the and trying to set up for software under the higher levels of software engineering, I'm going to mention here access is the first one. Which parts of a program can actually access an item, can use it directly? For variables and methods defined inside a defined inside classes, this is determined by certain keywords. By the way, variables defined, I'm going to mention, I'm not sure I remembered to mention it here, variables defined inside methods are called local variables, and they're completely isolated from the rest of the world. The more isolated something is, the better. You're going to probably figure out by the time I'm finished with this, or in a few days, after doing some exercises, that I'm very, very interested in isolating things. You allow access only as much as needed, and you restrict it if at all possible. The three words that are used are public, private, and protected. The only two we're going to use is public and private. Protected will occasionally turn up, but I tend not to use it because it's sort of a no man's land that I don't think is very adds very much to what we're trying to do here. And so I think two words is enough, but I will mention the other. When you label something public, you're saying that any part of the program may touch it and use it directly. If it's a method, it may be called. If it's a variable, you can assign to it or get the value. Anybody can touch it. Anybody can use it directly. If you say it's private, on the other hand, only code inside that class can use it directly. Now, protected is a little more complicated, and it involves something we're going to talk about later called inheritance. That's the next subject we're taking up. And if protected says only code within the class or within the classes in the same package or within inherited can access it. It's sort of a catch-all, unfortunately. If you leave off all of the keywords and don't specify any, it's what's called package access. And I'm going to talk about packages in a little while. And again, what you should, however, strive for is every thing you define inside a class, variable or method, should be either public or private. And for instance variables, you have one choice, private. And that's going to be checked. When you write a class, when you create a class, the testing code I'm going to provide actually goes in and looks and makes sure you made those private. Best software engineering practice suggests this. It means the access to the variable can be controlled. And this is extremely important. We want to be able to control access to things. Methods that are not private should leave the instance variable in a consistent state. For methods that may leave it inconsistent should be private. For example, suppose you're storing a date using a month and a day, and the month is January and the date is January 31st, and one of your operations is just to add one day to the date. Simple operation. So now it's January 32nd. Well, that's not so good. So a method that does that should be private. It's not wrong to do it, but somebody's got to come in and clean that up. That better be February 1st after everybody's done working on it. January 32nd shouldn't be visible once that object should not normally be visible. So somebody should clean that up at some point. I actually should mention, I use this as an example, but never, 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 never create your own date class. It's just way too complicated. There are some methods that have special names. We're going to see examples of these. A getter method, more formally called accessor, but I'm always going to call it a getter. Doesn't have any parameters, always returns a value. That's all it does. Makes no change to this object, it just gives you a value. Typically it's going to get you the value of an instance variable, but there are other uses for it too. A setter has one parameter. It doesn't return anything, but it assigns that value to an instance variable. So it sets one of the instance variables. These are important because this is the basis of how you manipulate objects, how you get values from them, how you set value, how you change them. A constructor, and we need these a lot, has no return type specified, not even void, and has the same name as the class, including capitalization. So those are three important categories of methods: getters, setters, and constructors. And in this first example, I'm going to create just those. getters, setters, and constructors, and we'll have a very usable class at that point. Constructors are called when a new operator is used to create a new object of the class. That's why it's called a constructor. It may have parameters. Usually those are used to give values to the instance variables. There's a couple of rules here. I'm going to state them, and they sort of complicated. In some ways they're complicated, but once you get using classes and writing examples, they'll become a little clearer. If you never define a constructor in a class, you actually get one for free called the default constructor. It does the very minimum possible. So it sets things up, puts some initial values inside instance variables, and then goes away. That's all it does. However, if you define a constructor, an explicit one, then the default constructor goes away. It's not available. That's a very that choice was made very specifically by the designers of Java.